Hello everyone. In this video, I'm going to explain electricity, which is module 7 of Science N3. This module consists of 3 topics. The first one is the cells. Second one is the electrolysis, Joule's law, and electric power. And the last one is transformer. I'll only do 7.1, which is the cells. You must be able to define electricity. It is defined as a flow of electrons around a circuit. The important terms, you must be able to define and calculate this concept. The first one is a potential difference. The symbol that is used to calculate the potential difference is V. It is defined as that which causes current to flow between the 2 points in a conductor. The SI unit of a potential difference is volt, which has a symbol V. So potential difference unit is a volt. Also a symbol that is used to calculate potential difference is V. A volt, when you get a single volt, you get 1 volt when current is 1 and the resistance is 1. So it is that potential difference which causes 1 ampere to flow through a resistance of 1 ohm. Another concept, the resistance. The symbol that is used to calculate resistance is capital letter R. It is the opposition offered to the flow of electric current. And the SI unit of a resistance is ohm. It is measured in ohms. Electromotive force, EMF, of a cell is the total energy supplied to 1 coulomb of electric charge. It's the measurement of the energy that causes the current flow through a circuit. So EMF is measured in volts, just like potential difference. When the circuit is closed, the reading that you get across the battery terminals, when you measure the voltage, is the potential difference. But when a circuit is open, the reading that you're going to get will be that of EMF. So you get EMF when the circuit is open and you get potential difference when the circuit is closed. The components, as N3 students, you are all familiar with this component. If everybody knows what is the resistor symbol, what is the variable resistor symbol, switch, cell, battery, ammeter, voltmeter, and galvanometer. And on the right-hand side, these are the function of these components. The cell. A difference between the cell and the battery. When we see a single battery, we call it a battery, but in science or in physics, that is called a cell. But when you see more than one, it's called the battery. Several cells that are connected together, they make a battery, although now we refer to a single cell as a battery. The knowledge of Ohm's law. You must be able to state this law and apply it in calculation. Ohm's law states that the current flowing through a conductor is directly proportional to the potential difference across the conductor, so long the temperature is constant. Cells that are connected in series. The cells of this battery, 1, 2, 3 cells, it consists of 3 cells. They are connected in series. Now, when the cells are connected in series and you are given the EMF of each cell, if each cell is 2 volts, for example, the total EMF will be 6 because it's 2 plus 2 plus 2, or it's 2 times 3. So when cells are connected in series, you need to know what will be the total EMF, what will be the total resistance. Now let's talk about symbols first. The capital letter R, it refers to all the external resistors of a circuit. So if you had an ammeter and the resistors that are external, we call what is inside the battery an internal, and everything that is outside the battery is their external resistance. It has external resistance. So the symbol for the external will be capital letter R. But a battery also has internal resistance. And the symbol for that internal will be small letter R. It's the internal resistance of a cell. I is the current. EMF is the electromotive force of a cell. Now, when cells are connected in series and you are given EMF of each, you're going to add, depending how many cells are connected in series. Or you can simply say number of cells times the given EMF of each cell. Some question will give you total EMF for the battery. Some question will give it for a cell. So what we see here is the battery because it's more than one. If it's given for a battery, you don't multiply by number of cells because that is the total. But if a question that is for each cell, you need to multiply to get total of the battery, which will be this formula, or you add all the cells. When you calculate the internal resistance, only if they are connected in series, depending on the number of cells that are connected, it will be R1 plus R2 plus R3. Then it's going to give you the total of what is internal. Then to calculate total current or the current across component of a circuit, any component of a circuit, we can use Ohm's law. The I stands for electric current. V is the voltage, or it can be EMF. R is the resistance, that is Ohm's law. But if a circuit is closed, remember when the circuit is closed, there will be that voltage drop in the cell or in a battery. So this I will be equal to the EMF, which is the total voltage, divided by R. This R is for the external resistance, and the small letter R will be for the internal resistance, which is the total. But when cells are connected in parallel, you have 3 cells that are connected in parallel. The formula to calculate the small r, the internal resistance. So when you are given a resistance of each cell, to calculate the RT, we're going to use this formula, 1 over R1 plus 1 over R2 plus 1 over R3, depending how many cells a battery has. Then, to make RT the subject, you must do the inverse of your answer. Or this formula can be written like this. For a parallel circuit, RT equal to 1 over R1 plus 1 over R2 plus 1 over R3. If there are 3 cells, you put brackets and inverse. So this is going to give you the answer. Of the parallel circuit or the parallel cell. EMF. When resistors or when cells are connected in parallel, the voltage is the same. So total, if a question says these 3 cells, they have a total EMF of 2 volts. It means the EMF of cell 1 is equal to this EMF, also equal to this EMF, because they are connected in parallel. So on a parallel section, whether it's a resistance or cell, the voltage is the same. Calculation, we use Ohm's law. Also, When internal resistance of a battery is considered, you add it to your total external resistance. Now let's look at this activity, 7.2. For the circuit diagram below, calculate the total resistance of the circuit. So when resistors are connected in series, we have seen the formula that you say R series is equal to R1 plus R2 plus R3, depending how many cells are connected in series. So I'm going to answer this question. I'll first sketch this circuit. This is the given circuit. EMF is given as 8 volts. First question says calculate the total resistance. It's a 4. There is no resistance yet. 7586. Okay. And you are given only a battery has only one cell. So this one is not supposed to be here. This is the second. So to calculate, when you calculate the total resistance, you always start far from the battery. So this is the point that is far from the battery. Then you work it towards the battery from the back. So what we have here is this resistor and this resistor. They are connected by this one conductor. There is no junction. So this will be, since it's external resistor, it will be capital letter R. But we're going to call it series 1. So R series 1 will be R1 or R8 plus R6. So it's simple, 8 plus 6. And R series 1 will be 14 ohms. So you always collapse the circuit from far from the battery. Now I will sketch what will be the remaining circuit after these are added together. The battery, this 4 is still there. The 7 is still there. 5 is still there. But these two, they are now one resistor. This is 14 ohms. This is 5 ohms, 4 ohms, 7 ohms, 0.4 ohms, EMF equal to 8 volts. Far from the battery, we have this and this. They are connected in parallel. So these two will give us RP1. It's external resistor. I'm using capital letter R. So if they are parallel, the formula is 1 over all to the power negative 1. So it will be 1 over 5 plus 1 over 14 all to the power negative 1, the inverse. Get the R parallel. So when you use the calculator, you insert this on a calculator. The answer of this will be 1 divided by 5 plus 1 divided by 14. Is 3,684. 3,684 ohms. So you just insert this as it is on a calculator. That is the answer for the parallel resistance. Now I'll sketch what will be the remaining circuit when this is collapsed. 7 is there. The parallel resistors are 3,684 ohms. And there is this 4 ohm. There is a battery. 0.4 ohm plus 8 volts of EMF. So the circuit is like this. 7 ohm is there. 4 ohms is there. That far from the battery. This is far from the battery. You work towards the battery. So 7 and these 3 are just connected by this one conductor. There is no junction, so they are series. We had the series 1, so this will be series 2. This is the second connection that is series. So it will be RS2. RS2, when they are series, is just 7 plus 3,684. And the answer will be 10.684 ohms. Now the circuit, when these become one resistor, the circuit will be like this. There is only this side, there is a cell of 0.4 and EMF of 8 volts. But this side, this is one resistor of 10.684 ohm. This is 4 ohm. So far from the battery, these two, there is this junction here, so they are parallel. They are parallel. If they are parallel, we already have parallel 1, so this will be RP2. So parallel resistance is 1/4 plus 1/10.684 bracket inverse, because they are connected in parallel. Use the calculator to get the answer. So it's 10.684 plus 1/. Plus 1/4. The answer is 2.910. Is 2.910 ohms. Now the remaining circuit, after this has been collapsed, this is now one resistor. So when this is one resistance, the remaining circuit will be like this, 2.910. The remaining circuit will be like this. This is the battery. 2.910 ohms, 0.4 of the internal resistor, and 8 volts of the EMF. Now this is the series circuit. So since there are only 2 resistors, they will give us the total resistance. So RT will be 0.4 plus 2.910. And the answer will be 3.310. That is the final answer. So we got the total resistance of the circuit, which is out of how many marks? Out of 4 marks. Now the total current. The formula to calculate total current is Ohm's law. IT is equal to EMF, which is total voltage, divided by total resistance. So this RT includes everything, even the internal resistance. So you don't include it again, it's already included there. So IT will be equal to total voltage is 8 divided by RT is 3.310. And the answer here will be is 2.417, 2.417 amps. That is the total current for 2 marks. Last question says calculate the voltage drop at 5 ohm resistor. You are looking for the voltage drop at 5 ohm resistor. It's for 6 marks. It means it's a lot of work to do. Now, when we analyze this circuit, now the current from the battery is split here, and the current of 7 ohm is the one that will be supplied to this side from negative to positive. So the voltage across the 5 ohm and the voltage across these 2, which is 8 and 6. The voltage across this 8 ohm and 6 ohm will be the same as the voltage across 5 ohm. So if we can get the total voltage of this section, it will be the voltage across the 5 ohm resistor. Now, how do we calculate the voltage across this parallel section? Let's look at this circuit. If we can get this voltage, the total voltage, it will be the voltage across 5, because this part is parallel circuit. Now, to get this voltage, we need a current that goes into this junction. So the current that goes into this junction is the current across the 7 ohm resistor. So we need to calculate I7, since this is 7 ohm. So we're going to label it as current across the 7 ohm. Now, we already have, we need I7, we also need the RP. Remember, when we add this and this, it was 14. And we use parallel connection to get a total of, we use parallel connection to get a total of 3.684. So what we need to calculate that voltage, RP is 3.684. I7 is unknown. Then V parallel, which is the voltage across this section, is also unknown. Now, since this section is parallel, or let me use the second circuit. Since this section is parallel, the voltage across here is the same as the voltage across here. So V5 will be equal to this V parallel. To calculate I7, this is positive, this is negative. To calculate this I7, we must first get what is I4. So we also need the value of I4. Now we do have R4, but we need V4. So let's first get R4, I4 and V4. Voltage across parallel is the same. So if you can take a voltmeter to measure the voltage across this battery, it's going to give you a reading that is less than 8 because current is flowing. We get potential difference. So you're going to get a potential difference across this battery terminal. And this potential difference is equal to the voltage across the 4 ohm. Potential difference will be the same as the voltage across the 4 ohm resistance. So if we got the potential difference, it means we're going to get the voltage across the 4 ohm. Now, this voltage across the 4 ohm resistor, we can use it together with this 4 ohm to get I4. Now, this current from the battery is IT. And this IT splits into this current and that current. So if from IT we subtract I4, we're going to get I7. From IT, we subtract I4, we are going to get I7. Now let's do it. Potential difference, PD, will be equal to, this will be the value of potential difference. The potential difference across this battery or this cell will be equal to EMF minus what is lost in the battery. So a voltage that is lost in the battery will be current multiplied by this 0.4 because it's lost due to this internal resistance. So potential difference will be equal to EMF minus IR. IR is voltage. Ohm's law is I equal to V over R. So when you make voltage, the substrate is IR. So small letter r is for the internal resistance. EMF is given as 8 minus the total current, which is the current of the battery, is what we calculated last. The current of the battery is 2.417. So is 2.417 multiplied by 0.4. So then we can calculate the potential difference across the battery. It's 8 minus 2.417 times 0.4. And the answer is 7.033. 7.033 volts. That is the potential difference. So this potential difference, as I have mentioned, it will be equal to a voltage across the V4. Because V4 is connected, this is V4. V4 is connected in parallel with the battery. So the voltage across the battery is the same voltage here. Now that there is a value of V4, we can calculate I4. because I4 will be equal to V4 over R4. V4 is equal to same as potential difference. So it's 7.033 divided by R4 is 4 equal to, I divide the last answer by 4. It's 1.758. 1,758 amps. Now, there is I4. We can get I7. I7 will be equal to what? Because you have a battery. The circuit is like this. Okay. These are 14 ohms. When you add the 8 and 6, this is 5 ohm. This is 7 ohm. This is 4 ohms. So IT is 2.417. And this IT splits into I4 is 1.758. Now we can get I7. I7 will be equal to IT minus I4. This minus this, you're going to get the current that goes that side or that way. So it's 2.417 minus 1.758. The answer will be 0.659. 0.659 amps. That is I7. Now that we have I7, I7 is the current that splits there. So I7 is also total current across this parallel connection. So for this parallel connection, we do have IP, which is equal to I7. We also have RP that we calculated when we're calculating the total resistance. So we can get VP. So VP is equal to IP multiplied by RP. It was RP1. Current total of this connection. So when you calculate the voltage of the total parallel connection, it will be total parallel resistance multiplied by total current of this section. So the current in this section is I7, 0.659. So it's 0.659 multiplied by these parallel resistors. We calculated them earlier. Parallel is 3.684. So when there is this resistor, we put 3.684 equal to the answer is 2.427. 2.427 SI units is in volts. So this voltage across the parallel is also equal to V5. So V5 is 2.427 volts. This is how we calculate it. Voltage across, there is the final answer. V5 is equal to the parallel total. If resistors are connected in parallel, the voltage is the same. So once you get the total of this section, it is equal to V5. So it is a lot of work, that's why it is 6 months. When resistors or the parallel section parallel section, its total voltage is always equal. So the formula when you deal with a parallel section, you need VP, you need RP, you need IP. So a current that is flowing across it, also its total resistance, you can get its total voltage. Now, if the question was, calculate what is the current across this 5 ohm. The current across the 5 ohm. So to calculate the current across the 5 ohm, it would be I5. It would be I5 equal to V5 divided by R5. And V5 is 2.427 divided by R5 is 5. Then you use your calculator to get the answer. You divide it by 5. It's 0.486. This will be 0.486 amps. Now the current across this 8 and 6, it will be the same. So if resistors are connected in series, current is the same, but voltage is not the same. If the resistors are connected in parallel, voltage is the same, but current is not the same. So the current through 8 and 14, 8 and 6 is the same current. So to get it, you can simply say I7 because it's the total of the section and subtract what you already know to get the answer. That is how you calculate it. Thank you very much for watching.